Happy Wednesday. Feels like forever since we last met. There's one thing left to cover. Hypothesis testing for population proportion. There's again two methods. The critical value approach. Step one is the same. Actually, the steps are basically all the same except for the statistic we need to calculate. State your null. State your alternative. And there are three of them. You have the two-tailed, the right-tailed, and left-tailed. State your alpha, your significance level.
We went over this already, right? Yeah.
Red just applied to the
Yeah,
next
he
study.
just applies to
Okay, makes sense.
it's the 7 steps. 6 or 7 steps.
It's all the same, it's just a different value that you're calculating. That's the only difference. Determine your rejection region. Calculate your test statistic. This is what's different. That's the test statistic for a proportion hypothesis test. P hat minus P naught over the square root, P naught times 1 minus P naught over N. Determine if this falls in the critical region, and then state your conclusion.
So this one has, I'm gonna let it there go. Value approach.
This is the, no, there's the other one as well. There's two approaches. P-value approach. Again, start with the same. State your null, state your alternative. You have three options. Two-tailed, right-tailed, left-tailed. State your significance level. Determine your p-value, either from technology, which is the easiest, or reading the chart. I'll actually show you how to read the chart. Get the p-value from that. It's not difficult. We've done it before. Compare this p-value with alpha. Reject the null when p is less than or equal to alpha. And then state your conclusion. So June believes that 50% of first-time brides in the United States are younger than their grooms. She performs a hypothesis test to determine if the percentage is the same or different. Samples 100 first-time brides, 53 replied that they are younger. Use 1% significance level. So I'll do something like this first. What is the sample size? What were the rules for the confidence interval? For proportion? 2 options. That's a definite yes. Are there at least 20 in each category?
Yes.
Yes. I think that was it, wasn't it?
A third?
That's for me.
Okay. Yeah, 20.
Where you had to have 2 categories. You had to have at least 20 in each category. I think that was it. And then simple random sample. That's always the case. What is our sample proportion?
Said 20%. Okay, 0.5.
53 out of 100. State the null.
Can you see the question? 53.
Younger.
Oh no, it's 100.
Yeah, so if you got the P 100. Okay, 50%.
B is 0.5. What is the alternative?
The P is less than, because it's younger.
Does not equal. What's the level of significance?
0.1.
The test statistic. Oh, well, actually, skip the step. State when we're going to reject.
Which
Which means
is
You gotta circle
we
it.
need a critical value.
Wouldn't it be P not equal to 0.51?
That's the alternative.
Oh.
So what kind of test is it?
it's a 2 tilted.
we need Z alpha over 2. For 0.01,
It would be plus 1282. 1.645. Yeah, 1.645.
and 0.01.
So it's 1.645. Like that. Oh, that was the 10. So it's 2.576.
What was it?
2.576.
So 0.01. It was 2.576.
It's smaller than the larger than that's what we get issue if less than
Right? You reject it, run your test, it says it falls in the rejection zone, which is to the left of negative Z alpha over 2 and to the right of positive Z alpha over 2. Now let's calculate the test statistic. P hat, which was what?
0.5.
Minus P, or P naught,
0.5.
divided by the square root, P naught, times 1 minus P naught, divided by N, which is what?
Yeah, 100. You didn't put a 1. Minus 1. 1 minus.
What's 1 minus P naught?
0.5.
That's why it's just 0.5 times 0.5. .5 times 0.5 is 0.25. Square root of that is 0.05. Square root of 100 is 10. And that is 0.03 times 10 will be 0.3. 0.3 over 0.5 is 3 over 5, which is 0.6. See if I did my mental math right. Yeah. I did that quicker than it took for you to type it in. See, don't become over-reliant on calculators. Don't be over-reliant on technology, just wait till it rebels. You know, rely on your technology to make you breakfast and it decides you don't put rat poison in it. Does 0.6 fall in the rejection region? No, it's right in the middle. I'll write it that way to represent that it's not in the rejection region, it's outside of it. This means we fail to reject the null.
So,
I have a quick question. So you got 0.6 only because you rounded the 5 up, right?
I didn't round anything.
yeah, that's the answer directly. 0.6. So, the difference, because we gotta know the difference, I guess. So the difference is being like this, you're gonna put it. I have to pass it.
Between this and what we did before the break?
Yes.
That's Z, that's the only difference.
The Z.
The formula itself was different to find the Z, that's the only difference.
Oh, okay. Yeah,
Everything else
I
was
see the
everything else is the same.
Can you use other?
But I didn't notice.
Because the other formula is for means. This is not a mean, this is a proportion. But you have to use this one. Which means you have to be aware of what test you're performing. Is it a test on the mean or a test on the proportion? And if it's on the mean, remember there's two options. You either know the population standard deviation or you don't. Because that determines whether you calculate a Z statistic or a T statistic. Which I noticed on that quiz that I just graded.
You graded it?
What quiz was that? Was that quiz 9?
I was 10.
I don't think I've graded 10 yet.
No, you haven't graded.
Quiz 9 is the one I just graded. One of the questions asked for a test statistic in it, and almost everyone gave me the Z score when I'm supposed to be a T score.
And you be happy about it. Taking some deep breath.
So read the problem, make sure you're calculating the right score. Z is if you know the standard deviation for the population. T is if you don't.
That's when you use the 0.25.
Now T is, you have to use a T score.
Which way you use the 0.25? That is when
That's when you're trying to find sample size.
Then
And you don't know the proportion.
In that they give us Z point and T both. So how to get a which one we have which one? So we have to just compare that thing.
Z score is if for mean if you know the population standard deviation. T is if you do not.
Yeah, but even they give you both value in there. Like for example, 0.05 is for T score and Z score for 0.01, something like that.
You won't ever need both.
Is it like a mini tab thing in there? Is they provide like that so we?
I think they're giving you both
Uh-huh.
because they're not assuming what the standard deviation is. If it's the population or the sample.
So,
So again, you have to read the problem and determine, do you know what the population standard deviation is or not? That will tell you which one to use. Z or T. Conclusion. What were we testing? In this case, we were actually testing the alternative. We were performing a test to see if it was different than 50%.
There is sufficient, insufficient, because we reject sufficient evidence to support the claim that there portion of
Is it groom or grooms? It's something along those lines.
So I have, whenever you fail to reject, that's when you have insufficient evidence.
It depends on what claim you're testing. Are you testing the null or the alternative?
Oh, so this one we're testing the alternative.
The alternative is the one that we were testing. If you're testing the null, you would simply say there's insufficient evidence to reject the claim that the proportion of brides that are younger than the grooms is 50%.
Oh, so this one to support.
Right, but we're testing the alternative, so we write it this way to support.
That's what
You're never supporting the null. You either reject or fail to reject.
okay.
If it's the alternative you're testing, then there's either sufficient evidence to support or insufficient evidence to support. Before I move on, actually, we're just going to pretend that we did all this up in here. So I don't need this anymore because I'm doing the p-value approach. So the z alpha over 2 I don't need. Which means I also don't need this part here. If I'm doing it by hand, I still need the test statistic. Here's how you find the p-value without technology. What was the test statistic? 0.6. This is a two-tailed test, right? So look in your chart at z equals negative 0.6. Just remember, it's symmetric. Area to the left of negative 0.6 is the same as area to the right of 0.6. Let's make sure I'm doing this right. So look in your table, negative 0.6, find the area to the left of that. What do you get? So obviously this chart and the T chart, tables B and C are going to be extremely important for the third test, so you might want to have them handy.
B and C, right?
B and C. Standard, normal, and student T. So what's the area to the left of negative 0.6?
We have to see in table C.
This is B. We're standard normal.
So if you get 0.727, sorry, 0.7257 or 0.2743.
I want left of negative 0.6. I think one of them was left of 0.6.
So that'd be 0.27.
So 0.
0.2743. Double it. Because it's a two-tailed test.
6.
That's your p-value.
I think it's on the C chart.
What was our level of significance?
That's from the C chart, right?
That's from table B.
Table B.
Standard normal.
I think I'm confused. Oh, negative 6. I see.
Right, there's two table Bs.
I don't know.
Well, 2 pages of table B. One for negative Z values, one for positive.
Yeah.
What was the significance level? .01. How does this compare to .01? What is it? Fail to reject. That's the conclusion. For a T-score, you're going to have to use technology to find the p-value. Our table isn't, the table for t-values isn't, nice enough to do otherwise. find the p-value using your calculator, you want to use a 1 proportion z-test. Then it's going to ask you to input some values. P naught, which we said was 0.5. How many successes? We had 53 successes. Sample size, 100. And what is the alternative? And 3 options. Obviously, we wanted the two-tailed one here, so that's the default. There's your z-score. There's the exact p-value.
I can see it.
Which is actually really close to what we got from the table. This just goes to show you that the table is actually not exact. It is off by a little bit.
So one more time, you have the statistics 6, and then
You want stat test and you want the 1
7.
proportion z-test,
Okay, thank you.
which should be number 5 on that
It's
calculator.
number 5.
Again, we still see that that is greater than 0.01, so we fail to reject the null. Suppose a consumer group suspects the proportion of households that have 3 cell phones is 30%. Cell phone company has reason to believe that that proportion is not 30%. Before they start a big advertising campaign, they conduct a hypothesis test. Their marketing people survey 150 households, with the result that 43 of the households have 3 cell phones. Conduct this test at the 5% significance level. So again, before we even start, let's just write down sample size and sample proportion. So sample size is 150. What's the proportion?
0.43.
It's 0.3.
30%. So 0.03. 43.
Which is what is a decimal?
Oh, shit, people.
I'll stick, since it's a proportion to 4 decimal places, 0.2867.
How did y'all get
I
that?
ain't got it.
It's 43 out.
Oh, you gotta divide it. Yeah,
43 out of 150,
Oh,
because that's our sample size.
yeah.
What is the null hypothesis?
Is it two-tailed?
So I'll worry about two-tailed later. That's the alternative. Could. Since you answered this. not just 0.3. Then what is the alternative?
Same 0.5.
P is different from 0.3. And level of significance. And this is a two-tailed test. Do I want to figure out the critical value?
Two, 0.5.
I just want to go with the p-value.
You want to go with the p-value? Let's V should be 1.9.
It's a two-tailed, so we want z alpha over 2.
Says 1.960.
Yeah, it should be 1.96 for this one. Reject when z is less than negative 1.96 or is greater than positive 1.96. I do not like that word. There's a much better way to represent that.
So on the test, you're going to tell us which value to use.
You have to figure it out. I will tell you what approach to use. So I will tell you whether you have to use the critical value approach or the p-value
That's what
approach.
I
So that I will tell you. But that's all I'll tell you. That's mathematically the right way to write it. But
Which one is that?
Is it always less than or greater than, or is it less than?
it depends on the alternative.
So what
Why would
alternative
you
is
put
this?
like less than or?
It will never be or equal.
There's not-
Will it?
So what is that one?
I think it's just strictly less than. It's the p-value that's less than or equal to. For the critical value, it's not equal to. Because if you're there, if the z value is 1.96, you're not technically in the region.
Yeah.
Yeah, so it should be something close to 0.5.
Hmm?
Should be something close to 0.5. 0.05
What should it be?
is
This test statistical? I have no idea. P hat. Minus P naught divided by square root. Now, if I really want to get a good, accurate z, I shouldn't be using that decimal. I should be using the fraction. Otherwise, it's going to be rounding error, but I don't think that really matters. 1 minus 0.2867. 7133. Did I do that mental math right? I think I did. All over 150. And that I am not doing in my head. Other than the fact I know it's going to be negative. Let's see what this gives us.
Negative 0.69.
That's not what I got.
669? I don't know what I'm doing wrong.
Probably parentheses are wrong somewhere. That's like 9 out of 10 of the errors in calculus is incorrect use of parentheses.
But the parenthesis is only for the bottom two though.
That's for parentheses around both the numerator and the denominator to be safe.
Oh.
I got negative 0.360. Which does not lie in the rejection region. So we failed to reject H naught. Before I write out the conclusion, let's also find the p-value. Look at negative 0.360 on the table. What is the corresponding area? What kind of test was this? Double it. There's your p-value, 0.7188. Which is most was certainly greater than the 0.05, so you failed to reject. Right, again, if we use technology, stat test, the 1 proportion z test, P naught was 0.3, 43 successes in 150 trials, and we had non-equals. And so p-value about 0.7215. Right, notice the difference in the z-scores because I rounded the fraction. I used decimal instead of 43 over 150. That's what's causing the difference in the values. But it's not a significant difference. Conclusion. Were we testing the null or the alternative?
The alternative.
The alternative is the claim that was being tested. This time we actually include the significance level. Not number. What does that have? Insufficient evidence to support the claim at the 0.05 significance level that the proportion of households that have 3 cell phones is not 30%.
So what was our final answer at 0.7188?
That's the p-value.
So the p value is the one get from only.
Either the table, reading from the table, or using your calculator. But again, you can only find the p-value from the table if it's a z test. For the t test, you're gonna have to use technology because that t table isn't good enough to get you a p-value from. Even this table's not that good, but it's good enough for our purposes. But that t table is just absolutely useless for p-values. So that you will have to use your calculator for it. Oh boy. In a study of 420,019 cell phone users, 172 of the subjects developed brain cancer. It's actually not bad. 172 out of 500,000. Test the claim that cell phone users developed, oh dear. It's okay, I don't need to know how to spell.
It's understandable.
I did my time. Yes, you keep giving me that pop-up. Go away. Go. I said no. I don't want to learn more. Go away. Yeah, that looks better. Test the claim that cell phone users develop brain cancer at a greater rate than that for non-cell phone users, which was 0.0340%. Use a 0.005 significance level. Explain why we use such a low significance level for this test. So let's first explain why we're using such a low significance level. Okay, that's great. Took you what, 4 hours to respond to my text? God, I take 2 minutes and chew. So why such a low significance level for this test? What do we think? Not necessarily. Now, what does the significance level represent?
The amount of people that are delivering. Or the chance of delivering.
Because it could change.
Significance level is the probability of making a type 1 error. What is a type 1 error? I know this was before we gorged ourselves with turkey. I forgot everything, but let's try and remember.
It's basically like when you reject the null, right?
Reject the null when what?
When it's actually true. When the null hypothesis is actually true.
Right, reject
The null
the null
hypothesis.
when it is actually
True.
true. So we're using a low significance level, which means we want a very low probability of committing a type 1 error. Why would that be? Why would we want to reduce making a type 1 error?
Because you want a positive error.
What do you mean positive? We're talking about brain cancer. This is a pretty serious topic.
Yeah.
You really don't want to make an error. what was the other two we were talking about? One was cell phones, the other was about whether brides are younger than their grooms. Yeah, who cares? It's not really serious. I may have just committed a sin, because a lot of females actually do take the man has to be older very seriously. Cell phones, I don't think that's that big of an issue. But brain cancer, yeah, that's pretty big. That's why the low significance level here. That's even kind of high. I probably use a 10 to the minus 9 significance level. I really don't feel like working with these numbers by hand, so we're going to use the p-value technology approach. Because these values are typically very, very, very small. What is the null? What is it?
0.034? No.
That would be the 172.
420011.
You were looking at the right number, you interpreted it wrong.
0.03.
You want to divide that by 100.
Oh, 172 divided by 420.
You were looking at the right number, but you interpreted it wrong. You kept it as a percentage.
So 0.034.
P equals 0.00340. Divide by 100 means you add 2 zeros out in front. What is the alternative? What is it?
So B is
Is the same number?
is greater
Greater than.
Is greater than 0.
This is a right-tailed test. Not that Nazar's not doing it by hand. Significance level is 0.005. P naught was that. How many successes? So remember, in this case, its success would be developing brain cancer. What was it?
172.
Out of how many trials?
You try.
42019.
in this case, I'm going to do something different than I usually do with the p-value. I'm not going to use 4 decimal places. I'm going to use 3 sig figs. Because our proportion gives us 3 sig figs. So I come back to here. 1, 2, 3 sig figs. After the 7's a 5, that's going to round up.
To 8.
So 0.00728 will be the p-value I use. How does that compare to alpha? So what's the conclusion? Not the written out conclusion, just what do we do with H naught? Reject or fail to reject?
It's on reject. Fail to
At this significance level, we fail to reject H naught. Now for the conclusion. What was the claim we were supporting? Or not supporting, sorry. The claim we were testing. Was it the null or the alternative? The alternative.
All these writing. I was gonna make some money.
You think that's a lot of writing code here? Just wait till you have to do a case study. I assume you know what case studies are. My wife has to do a lot of them. They're not fun.
What do you like?
Some of them do be, but
My wife is about to become a nurse practitioner. She's going for a
Nice.
master's in nursing. What was that?
I said some of them do be, but when you keep doing them and they're repetitive, it gets.
It's just how much you have to write.
Yeah.
It's a lot of writing. And it's dull writing, too.
So we're gonna use the entire class time for the test. our last day.
It'll be 2 hours, which is a final exam period.
How many questions?
That's a good question.
We'll find out next week.
Are we gonna get a review again, like how we usually do?
I guess we'll find out after the break.
So next week's test?
It's gonna be
And then
divided.
that's the last class.
Gonna be divided. Are we having a party? We're gonna have a party, right? Yeah,
I'm gonna let you do this one on your own. Question 4.
yeah, it is. Oh, God.
Again, a lot of it is just preliminary information, really stuff you don't need. That's why it's so long. I don't feel like doing it.
Why is it not?
I'll tell you the. You should get rejecting null. Oh, the slides will be up there. I'll probably upload them sometime tomorrow. So you should get rejecting null for this one. I'll leave the rest to you.
Was this extra credit?
No. But it is good practice for the test. Ask me that question again.
Extra credit?
And if you get that reference, you're awesome.
Then you get extra credit?
Yes.
Yes, yes, yes.
I had yes.
Do we need to Google anything for this?
No, all the information you need is given on the 2 slides.
Oh, 2 slides. Okay.
Yeah, so it's a very long question because there's a lot of information in it.
Oh, yeah, I gotta take a picture of that.
It'll be posted sometime tomorrow.
Okay. I still want to just have it. Do you want us to submit it to you?
Is it one for us today?
You don't need to. Alright, so project 3, don't forget that's due tonight. Quiz number 11, the final quiz will be due next Wednesday. And test number 3 is next